is the part 2 of the chain rule. These problems I thought might be a little bit more taxing, more challenging, more fun. And so I cut the first part of the chain rule off, made it its own video, and then this one. So if you're wondering what happened, you might have missed the first part. So go find it. There's a link in the description that says previous video. So you can go back and see like some easier ones that sort of lead up to the here. So let's give it a try. And remember, what we're trying to decide is to do the chain rule. We have to determine what the outside is versus the inside. And let's look at this problem. Now this problem, if you start at the inside is this. Let's look at the first factor, 2x plus 1. Then as you work your way out, you come to these parentheses. Then you come to this power. So you have the inside, this power, and then farther out, you have a product. You have this factor times this factor. So the outermost outside is the product rule. So you start with the product rule, and every time you go through and do a part, you'll see it. We're going to loop back in. So let's start off with the derivative. And the product rule says it's the first times the derivative of the second plus the second times the derivative of the first. So it's the first times the derivative of the second. All right, now let's look at the second. That's this part right here. When we do the second, that part on its own is the power rule with something differentiable inside. So we bring down, I'm going to put this here like this so you can see it's going to start a new section. So we bring down the power, leave the inside alone. Take one off the power, loop back in, and take the derivative of the inside. So that looping back in is your chain rule, which you make the loops. All right, now, sometimes students lose track of what they're doing because they're so involved in the problem, they don't keep the big picture in mind. So we're not finished with this line because what we've done is the first times the derivative, I'm going to shorten that with just a d, times the derivative of the second. That's all we've got so far. Then we need plus the second, and that would be 3x minus 5 to the negative 2 times the derivative of the first. So this first factor is this part right here. Its outside is the power rule. So we bring the power down, leave the inside alone, take one off the power, loop back in, and take the derivative of the inside. You doing okay? Okay. Now, when you go through here and you have, if you look at it, this is one massive term. There's a second because this plus sign divides the two. So rather than to multiply all this out and get some really long function, what we're going to do is try to factor out things that are common. So let's look at the coefficients first. And this negative 2 times this 3 is a negative 6. And this negative 4 times this 2 is a negative 8. So what's in common between a negative 6 and a negative 2? How about a negative 2, right? Now, let's look at the binomials. So here, let's look at the 2x plus 1s. I have a 2x plus 1 to the negative 4th and a 2x plus 1 to the negative fifth. And you always factor out the smallest power. And which is smaller, negative 5 or a negative 4? Well, negative 5 is. So we're going to factor out a 2x plus 1, and the smaller power is a negative 5. We also have a 3x minus 5 there, and a 3x minus 5 in the second term. So I'm going to factor out a 3x minus 5. And which one's smaller, a negative 3 or a negative 2? Negative 3 is smaller. And that looks like all I can factor out. So we're going to go back starting from left to right and see what's left after I factored that out. All right, so going left to right, let me take all these out. Right, we had a 2x plus 1 minus 4, and I factored out a 2x plus 1 to the minus 5. So they're not a match, so I have some sort of 2x plus 1 left. Now, the question is, what goes right here that when I multiply this 2x plus 1 times this one, I'm going to add this power to negative 5 and have an equivalent to this negative 4. So what would I have to add to negative 5? Because remember, a base raised to power times the same base raised to power, you write the base down and add the powers, right? So what would I have to add to negative 5 to get to negative 4? It would be a 1, correct? All right. So this is a 1. And you don't have to show the 1, but I want you to know it's there. Now, we're looking up here, I had this negative 2 times this 3, which was a negative 6, and I factored out a negative 2, so that would leave me 3, and I'm going to put that in front. Then I had this 3x minus 5, and I factored out a 3x minus 5 to the negative third. So do I need something right here to multiply this by to be sure it's equivalent to up here? No, because I took them all out. Now, that gets me to the end right here. And now we're going to move on to the next one. So I had a 3x right here. We had 3x minus 5 to the negative 2. I took out a 3x minus 5 to the negative 3, so they're not a match. So I have some sort of 3x minus 5 left. So what do you multiply a 3x minus 5 to the negative 3 by? What's the power? So that when you add a negative 3 to whatever this is right there, you get negative 2 as an equivalent. Wouldn't that be 1? That's not always 1. Here we go. So this is to the first, okay? So that's taking care of this term right there. And I see students underline as they go to sort of keep themselves cognizant and in the problem so they don't get distracted. Now, moving left to right, I had a negative 4 times a 2, which was a negative 8, and I factored out a negative 2, so that would leave me 4. I'm going to put it in front. And that takes me to 2x plus 1. Now, I had a negative 5, and I took out a negative 5. So do I need a factor in there to add to this power to get this power back, or is it a match? What's a match? So I don't have any 2x plus 1s left behind. So I have negative 2 2x plus 1 to the negative fifth, 3x minus 5 to the negative 3. And then here, and you know, sometimes teachers will let you do this. I let students do this, and I'm pretty strict. So I'm just going to multiply this up here. So 3 times 2x is 6x plus 3 plus 12x minus 20. So when you add that together, you get 18x minus 17. Now, if your teacher's following the system where you return it, the answer in the form that's similar to the question that was asked, the question that was asked had negative exponents in it. And so I can leave these with negative exponents. If your teacher is adhering to the algebraic rules that we've learned before, then the 2x plus 1 and the 3x minus 5 would drop underneath in the bottom of a fraction. Okay, let's do y is equal to 3x squared minus x over x minus 1 to the fourth. Now, we've got inside the parentheses, we've got a quotient. And outside, we have this fourth power. So the outside is the power rule. Okay? So here we go. Y prime is. So you start with the outside and work your way in, which is the opposite direction from what you've learned all these years in algebra, where you started on the inside and worked your way out. So for this, for the chain rule, you work your way in. So how does the power rule go? You bring the 4 down, you leave the inside alone, because in previous videos you hear me say leave the x alone, leave the inside alone, take 1 off the power, and then you're going to loop back in and do the quotient rule. Okay, so all we have to do is look at this 3x squared minus 1 minus x over x minus 1 and apply the quotient rule. So the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So it's the bottom times the derivative of the top. The derivative of 3x squared minus x is 6x minus 1. Okay? Minus the top times the derivative of the bottom. And the derivative of x minus 1 is 1. And you don't need the 1, but I want you to see that we did it. All over the bottom squared. Okay? So we have 4. Now we have to keep copying this down so we don't lose it. But all of our work is pretty much going to be in here. So you're going to multiply these parts out and then try to add them up together. So you'd have 6x squared minus 7x plus 1 minus 3x squared plus x all over x minus 1 squared. So I think I can still do a little bit of work. Write all this down so I don't lose it. You'd hate to lose it 3 steps up and then have half your problem gone or all of it. All right, so this is going to go to 3x squared minus 6x plus 1 over x minus 1 squared. All right, so this is, now let's look. When we have these fraction looking things that we're going to multiply together, you know, you multiply across the numerator, multiply across the denominator. We don't want to actually multiply all these terms out. Okay, we want to leave them as factors. So let's group up what we've got. We've got this 4. We've got this 3x squared minus x. But see this 3 right here? It applies to what's in there. So don't forget the cube. And then I have this 3x squared minus 6x plus 1. And the reason I did that really is if you look down here with this x minus 1 and this x minus 1, they're the same binomial. So what we could do is to say I have x minus 1, and there's 2 here and 3 there. So a base, x minus 1, raised to a power 3, times the same base, x minus 1, raised to a power 2. You add the powers. So this is 5. I told you these would be a little bit more intricate, interwoven. These are kind of fun. I think they're fun. Okay. You may not be so sure about that right at the moment, but you'll get there. I swear you're going to get there. All right. So here we go. Y is x minus 1 to the 4th over x squared plus 2x to the 5th. Okay? Y prime is. Now let's look this over. All right. Let's kind of narrate our way through. We have this x minus 1 raised to a power. Then it's divided by another binomial raised to some power. So the outside is this quotient. Okay? Think of it as working your way out. You have the x minus 1. You work your way out to the power. You work your way out to include the denominator. So the outermost part is the quotient rule. So this part is the quotient rule. It's going to be the outermost part. So how does the quotient rule go? It's the bottom times the derivative of the top. Okay, now the top is the power rule. So you bring the power down, leave the inside alone, take 1 off the power, loop back in and take the derivative of the inside. Minus, okay, because it's bottom times the top, minus the top times the derivative of the bottom, which is the power rule. So you bring the power down, leave the inside alone, take 1 off the power, loop back in, and take the derivative of the inside, 2x plus 2, all over x squared plus 2x to the 5th squared. Okay? Don't throw things at the computer screen or your phone. All right. Don't throw things. All right. So here we go. If you need to stop the video and go get a glass of water, all right, and come back, I would thoroughly understand. And if you need to pause it and watch that again, totally understand that too. All right. Now, what we have to do is do the best we can to sort of clean this up. All right. So this 4 times right here, this 4 times x minus 1 cubed times 1 is just going to be 4 times x minus 1 cubed, right? And this 5 times x squared plus this other stuff, there isn't anything really here. You could, I guess, factor a 2 out of there. You want to factor a 2 out? Maybe we'll get something interesting. So this is 2 times x plus 1. You cannot factor an x out of the x squared plus 2x to the 4th unless you take into account the fact that it's got a 4th power. There's kind of a tricky way you can get some out, but let's not deal with it just right this second. Okay? So let's go. So we have a 4. Let's look at the coefficients. There's a 4 in this term and a 5 in this term times this 2 right here that we just factored out. So this 2 and this 5 make 10, right? So there's a 10 right here. Now, so 4 won't factor out of 10, but 2 will. So I'm going to factor out a 2. Okay. Now, there's an x squared plus 2x in both terms, so I'm going to factor out an x squared plus 2x. And from the first term, I have a 5. And from the second term, I have a 4. So which one's smaller? The 4. So we're going to factor out the 4th power. Now, this 4 I already took care of. I factored out that 2. Because that's the best I could do with the 10. This one has an x minus 1 factor, as does this one. So I can factor out some part of the x minus 1. And if I have an x minus 1 cubed and an x minus 1 to the 4th, which one's smaller? The cube. So we're going to factor that out. And then we're to the end of this term. So if it wouldn't come out of the first term, it's not going to come out of the second. So here we go. I'm factored out a 2 and I had a 4. So there's 2 still there. Right. I had an x squared plus 2x to the 5th. I took out an x squared plus 2x to the 4th. So there must be an x squared plus 2x to the 1st still left, so that 4 plus 1 equals this 5. Okay? You should always look back and make sure that what you did is equivalent to what you had. You had an x minus 1 cubed right here, and I should probably use a different color. You had an x minus 1 cubed there, and you took out the x minus 1 cubed there, so there's no x minus 1 cubes left. All right. Minus. I had an x minus 1 to the 4th. I took out I had an x minus 1 to the 4th. I took out an x minus 1 cubed, so I have an x minus 1 left. I had a 10. I took out 2, so I have 5 left. I'm just going to squeeze it in right there since I didn't leave any room in the front. I had an x squared plus 2x to the 4th right here, and I factored all of it out, so there's none left. And I had this 2 times x plus 1, but the 2, this 2 is being used with the 5 to make 10. And here's my 5, right? So, but I had an x plus 1, and I didn't take any of that out. Now, are you done with this calculus part? No. Don't forget the denominator. Okay, and x squared plus 2x to the 5th raised to the 2nd. These two powers right here multiply. So you have x squared plus 2x to the 10th. Okay, so you have 2x squared plus 2x to the 4th times x minus 1 cubed. And when you clean all of this up in here, right, you would have 2x squared plus 4x minus 5x squared plus 5 all over this. A little bit more. Okay, what do you think? Are you done? See anything else you can do? think there is. All right. So see this x squared plus 2x to the 4th? And see this x squared plus 2x to the 10th? Those are factors, right? See all these times in here, this one times this one times this one. These are factors, so they can cancel. All right, and if you have 4 in the top and you take them out of the 10 in the bottom, you have this. And now you're done. And like I said, don't throw things at me. Don't say anything naughty. Don't throw anything at me. This actually can be kind of fun. Really. Don't throw anything at me. All right. So we can do this. All right. One more. I actually had a couple more, but we're going to cut it with one. So y equals 3x minus 4 to the negative 4, 8x plus 3 to the negative 3 squared. Okay, you can do this. All right, so working your way out, you'd have the 3x minus 4 to the negative 4th times 8x plus 3 to the negative 3, which is a product, all raised to the second power. So the outer part is 2. It's a power rule. Inside is a product, and inside the product is another power. Okay? So y prime is, to do the power rule, you bring the 2 down. You leave the inside alone, all of the inside. Take 1 off the power. Ready? Loop back in and take the derivative of the inside. And the inside is this product. Really don't throw anything at me. All right, ready? You can do this. Look at it this way. If you can do this one, you can probably handle just about anything your teacher's going to put on the test, right? You'll be prepared. Life is good. Here we go. How does the product rule go? It's the first times the derivative of the second plus the second times the derivative of the first. All right? So it is the first. As is. Times the derivative, excuse me, of the second. All right? So we would bring down the minus 3, leave the inside alone, take 1 off the power. Well, minus 3 minus 1 is minus 4. Loop back in. Don't forget to loop back in. Take the derivative of the inside, which is 8. I don't know if it's going to fit on the screen. Okay. Plus the second times the derivative of the first. So the first is that 3x minus 4 to the negative 4, which is a power rule. So you bring the power down, leave the inside alone, take 1 off the power, loop back in and take the derivative of the inside. Okay, you can do this. All right, so you should stop. Okay, stop the video. See where you can get with this. All right, and then come back and see if we match. Okay, kind of get some verification. So if you want to, stop the video, go do what you need to do. Okay, take a break, maybe try this one. All right, build up some confidence. So right in here is a plus sign that's going to separate those two binomials. So let's gather up what I've got. that isn't really anything I'm trying to clean up. Okay, so that's just the first part. Now look between here and here and see if there's anything we can factor out. So between here and here, I have a negative 24. And between here and here, I have a negative 12. Okay? You think we could factor out a negative 12? You know, maybe I need to change this color so you keep up where we're at. Maybe that would help. So we're handling this part right here. All right? So we factored out a negative 12. And then let's look at the binomials. This term has a 3x minus 4, and here's a 3x minus 4. So we're going to factor out some type of 3x minus 4. What's smaller, negative 4 or negative 5? Oh, negative 5 is smaller than negative 4. We're just trying to find out what we're going to factor out. Okay, we have an 8x plus 3 here and an 8x plus 3 over there. So we're going to factor out an 8x plus 3. Which is smaller, this negative 4 or this negative 3? That would be negative 4. All right. And now we're going to see what's left. So I'm going to change colors so you can see it. All right. So here we go. Let me underline this as we go. Maybe it'll help you keep track of where we're at. I had a 3x minus 4 to the negative 4th, and I took out a 3x minus 4 to the negative 5th. Okay, so it's not a match. So I must have some sort of 3x minus 4 left. What do you add to negative 1 that would make this multiplication equivalent to negative 4? I'm sorry, did I say negative 1? Negative 5 to make it equivalent to negative 4 when I multiply. So that would be a 1. Okay. I had this negative 3 and this 8, which was negative 24, and I took out a negative 12, so there's 2 left, right? I also had an 8x plus 3 to the negative 4th right here. This is where we're at. Okay, we're down to here. And I took out all of them, so there's no 8x plus 3's left. Okay, plus. I had an 8x minus 3, and I have factored out an 8x plus 3 to the minus 4. So there's some 8x plus 3 left. And what do you have to multiply the negative 4 term by to add the powers to get to negative 3? So this would be a 1, just like this was a 1. I had a negative 12, and I factored out all of the negative 12 because we're to this part. And I had a 3x minus 4 to the negative 5th, and I took it all out. So that's what this looks like. Okay? So I have 2. 3x minus 4 to the negative 4th, 8x plus 3 to the negative 3rd, negative 12, 3x minus 4 to the negative 5th, 8x plus 3 to the negative 4th, and in this part, okay, I have 6x minus 8 plus 8x plus 3, so I have 14x minus 5. You okay so far? All right. Now, do you see anything that looks kind of the same that I could combine? Well, I have this too, and this negative 12. And those can multiply together and get negative 24. And I have this 3x minus 4 and this 3x minus 4. So I have a base of 3x minus 4. And a base raised to power times the same base raised to power. You write the base down and add. So negative 4 plus negative 5 is negative 9. We're almost done. Okay? Then you say, okay, now here's an 8x plus 3. And there's another one down here. So if you have a base raised to a power times the same base raised to a power, you write the base down, add the powers, and don't forget this 14x minus 5. And this is your derivative, all cleaned up. And you should be very proud of yourself. This was a lot of work, a lot of mental energy used. Some of you may be like, I really kind of like this. And some of you may be, I really kind of hate this. And I get it. I really do. All right. But it's great mental exercise. And if you have to do something, you can either do that thing, kind of grumpy, or whatever, or you can try to find some humor in it. So do try to find some humor in this. It's not going to go away. So do try to find some way to smile, even if, it's sort of laughing at yourself, or you can laugh at me. Okay, so laugh at me, laugh at the fact that I have all these silly jokes that I think are funny, or that, I make little mistakes and have to go back and fix it. So laugh at me, that's fine, but, try to smile. Okay, I know it's hard sometimes, but do try. All right, so I will see you in the next video, which is going to be the derivative of trig functions, and we'll see how that goes. All right, because when we do those, we now know the chain rule, and we can actually do the chain rule with trig functions, but thank goodness they're not normally this intricate. Okay, all right, so I will see you in the derivatives for the trig function video.